Okay, we're going to look at the operations and composition of functions homework. So the first thing that we have is it wants us to describe what f of negative 3 means. So f of negative 3 says or it's asking for the output when we input a negative 3. So to find it, f of negative 3, that's going to be negative 3 squared plus 4 times negative 3. So I just input it in place of those x's. So you can see I put negative 3, I squared it, negative 3. Okay, so then we just simplify. Order of operations says to do our exponent first, so that's 9 plus, and then we'll multiply 4 times negative 3 is negative 12, so that ends up with negative 3. So f of negative 3 ends up equaling negative 3. Okay, so we can do this with other inputs as well, not just a negative 3. So if you look at the next part, it says f of x plus h. This again is the input. So if we want to find it, we're going to plug that in just like we did for all of the x's. So instead of x, you're going to write x plus h, since that's the input. Then it needs to be squared. And we're going to add 4, again, times that same input. Then to simplify it, we are going to square x plus h, which is really x plus h times x plus h. So to distribute that, we'll get x times x is x squared. We'll get x times h, which is just xh. H times x, which is another xh, and then h squared. Then we'll distribute 4 times x and 4 times h. So if we simplify all of that, we're going to end up, it looks kind of a mess. The only things that can really go together, like terms, are xh, xh. So we're going to have x squared plus 2 of those xh's plus h squared plus 4x plus 4h. Okay, so that right there is f of x. So it says now that you found f of x plus h, it wants us to evaluate f of x plus h minus f of x. Well, f of x plus h, again, we just found it. I'm going to rewrite that. X squared plus 2xh plus h squared plus 4x plus 4h. So again, that's f of x plus h. Then it says, okay, minus, I'm going to put it in parentheses to make sure I subtract everything for f of x. And if you remember, f of x, going all the way back, was x squared plus 4x. So then what we have, if I distribute that negative x squared minus 4x. And the whole beginning part stays for a second anyway, because then we want to notice our like terms. And we actually have an x squared and a minus x squared, so those will cancel. Then we have a positive 4x and a negative 4x, those will cancel. So all we have left is 2xh plus h squared plus 4h. So that's what f of x plus h minus f of x is. Now there's something called the difference quotient, which takes basically what we just found, f of x plus h minus f of x, all over h. It's a very common function that's found in calculus. So if we want to evaluate the difference quotient here, we already found out what f of x plus h minus f of x is. It was 2xh plus h squared plus 4h. Now we just need to write that all over the h. That was the denominator. And so if we want to simplify that, if you notice, everything has an h. We can factor an h out of the numerator. And then what you can do is actually simplify those h's, because h over h is just 1. So what we just found the difference quotient to be for this particular f of x is going to be 2x plus h plus 4. So that is our difference quotient. Now ask, what would the value of the difference quotient be when x equals negative 2? So if I'm trying to find that, and again, we're just looking at the step right above, if I put in an x value of negative 2, this will be 2 times that negative 2 plus h plus 4, negative 4 here, plus h plus 4. The negative 4's will cancel, we're just left with h. Now the next question says, okay, well, what's the y value approaching if we allow h to become 0? So again, our function right here, this is our difference quotient. And we were just asked to plug in a -2, which we did, and it ended up that we just had h. So now the output, if h is going to 0, then our y value is just going to be 0. Not that exciting because all we have here is that h. All right, next we have 12 over x. It wants us to evaluate that difference quotient again. So that means that we're going to find f of x plus h minus f of x and write that all over h. So f of x plus h, let's find that part first. That's just looking at the function, and our input is going to be x plus h. So it's really just 12 over x plus h. Then it says minus the original function. So the original function is 12 over x. And then this is all over h. If we want to simplify that, we can create a common denominator for the numerator. So we have x plus h and x, and multiply over here by x plus h, and on the other side by x over x. So it looks like the numerator will be 12x, and then I'm going to take the -12 times those two pieces. That's -12x minus 12h. And that's all over that common denominator of x times x plus h. And that's still all over h. Now remember we talked about that if you're dividing a fraction by something, really the denominator here is h over 1, it's multiplying by the reciprocal. And actually right before that, I just noticed that this 12x and that minus 12x could cancel out. So really all I have on the top is -12h. That's over x times x plus h. And this is all over the h, or h over 1. So I'm going to multiply by the reciprocal 1 over h. And so this will be a -12h over h times x plus h. Remember when we have the same variable on the top and the bottom, those can cancel, so h over h cancels. We have -12 over x times x plus h. That is going to be our difference quotient. Now I'd ask for one more thing, and that was to figure out what happens to this difference quotient as h becomes 0. So if we look at this, as h goes to 0, really that's getting this h getting little, like it's going away. All it's going to be left is -12 over x squared. All right, for part number 3, again, we're going to do the same thing. The difference quotient is f of x plus h minus f of x all over h. And this time we're looking at the square root of x plus 3. So we want to input x plus h into that, so it's going to be the square root of, it'll be x plus h now instead of just x, and then plus 3, minus square root of x plus 3. And this is all over h. Okay, so we just found the difference quotient. Yay! Now it does say we can rationalize the numerator, which means to eliminate the radicals from the numerator. So one way that we can do that is multiplying by something called the conjugate. You guys remember that? All right, if you don't, it's the same exact thing, but with the opposite sign in the middle. And I'm going to do it to the top and the bottom just to keep everything balanced, because really this is multiplying by like a 1. So the really cool thing that happens, and it doesn't look cool yet, it's kind of hard to see, is that if you multiply the numerator, because they're conjugates, right, a plus b, a minus b, this is really just taking the first thing squared minus the second thing squared. And this also might look familiar if we think going the other way, that's the difference of two squares. So really what's happening for our numerator is that first guy squared undoes that square root of x plus h plus 3. And then that's going to be minus, if we square that second thing, it'll just be x plus 3. And then in the denominator, we'll have h times, now that one doesn't look very pretty, x plus h plus 3 plus the square root of x plus 3. But what happens in the numerator, the minus distributes. We get a negative x plus 3 over here. And, negative x minus 3, because it distributed. And our beginning part right here, x plus h plus 3, we're going to actually have some canceling that happens. our x's will cancel, the 3's will cancel. All we have left is h, but even h will cancel with the h down below. So really on the top, all we really have is a 1. So this is 1 over the square root of x plus h plus 3 plus the square root of x plus 3. That's our difference quotient. All right, so we played around a bit with all of those function notations and operations. Let's go into that new function that we've been talking about, which is composition. So it says that we want to find f composed with g of x. And so we've been rewriting that and saying, okay, well that means we need to plug g into function f. So here the g is 2x plus 1. It's got to plug in to function f into the two spots where x is. So we're going to have 2x plus 1, and we will be squaring it because that's what the function does to inputs. Then it subtracts 4 times that 2x plus 1. So simplifying, we have 2x plus 1, we'll square that. That's 2x plus 1 times 2x plus 1. If we distribute, it'll be a 4x squared plus a 2x plus another 2x plus 1. And then minus 4 distributing gets negative 8x minus 4. So combining our like terms, 2x and 2x will go with the negative 8x. That makes us have a negative 4x. And then we have 1 and negative 4, that makes negative 3. And 4x squared doesn't have anyone to go with, so we're left with 4x squared minus 4x minus 3. So that's the composition. That's the new function we just made. So then the last part here says we want to plug in a negative 3. So f composed with g of negative 3 is equal to, I'm going to plug negative 3 in again for everything. I'm going to leave spaces for it. All my inputs get that negative 3. So order of operations says square first, do our exponent first, so that's going to be a 9 times the 4. And then we have minus 4 times negative 3 minus 3. Multiplying, that will be a 36. Negative 4 times negative 3 is plus 12 minus 3. So we're going to have, let's see, that will be 48 minus 3. So we'll get a 45. All right, let's look at f here. It wants us to again do the composition, and then it wants us to do a little bit of simplifying so we don't have a crazy looking fraction. So let's see what that would look like. F composed with g, oops. So we're gonna take function g and again plug it in where my x's are. So that's gonna look like f composed with g of x will be equal to 9 over x squared minus 16 all over 9 over x squared minus 16 minus 1. Okay, so that's just plugging it in. And again, it's kind of complicated because it's got like fraction within a fraction. So let's clear out some of those fractions. And the way that we could do that is multiplying by the denominator that you see in a couple places, that x squared minus 16. And so again, you multiply it by top and bottom because that's really just multiplying by 1. So it's changing what it will look like, but not its value. So when you multiply within the numerator, it's really x squared minus 16 is like whole, so it's going to end up being able to reduce with that denominator. So on top, we'll just have a 9. On the bottom, when this x squared minus 16 distributes to both these pieces, with the first fraction, the x squared minus 16 cancels, leaving, again, just a 9. And then we're going to get minus 1 times x squared minus 16. So this is going to be 9 over 9 minus x squared plus 16. And if we simplify that a little bit, the 9 and 16 is 25. So we're getting 9 over 25 minus x squared. So kind of just a little bit of playing with fractions, trying to get a little more comfortable with fractions. All right, for number 6 here, we're looking at this function, and now we're using the similar notations that we've been using, but we're going to look at a graph. So when we're looking at f plus g of negative 1, that's just f of negative 1 plus g of negative 1. I don't have any function to, like, equation to plug into, so I just have to find these function values. So just to kind of be clear here, it might be nice to see that, okay, g of negative 1 is talking about an input of -1, so then that would go down to here. This is going to be g of -1, which has an output of -3. F of -1 is going up the other way, and that has an output of 2. So adding those together, it will make a -1. F times g of 4, that's just f of 4 times g of 4. And so if I go to the 4, f of 4, let's make sure we highlight this. So this is function f, just not to be confused, and then function g. Okay, and it's filled in this whole way. It does have open circles on the endpoints, and so does function f. Oops, and I just mixed that up there. That'll be open circle, and I covered it up. This guy actually has a closed dot. Okay, so f of 4 is going to be this purple guy here, which is -1, times g of 4. That's going to be right there at 0. So we'll get 0. Now g minus f of 1 is g of 1 minus f of 1. So again, we're going to our input of 1. We want to go down to the g, get that. That's a -1 output. Then go up to the f. That's a 2 output. And subtract them. So we get -3. Now g divided by f of -3 is g of -3 over f of -3, really. G of -3, so now we're looking at our x value of -3. We can find g of -3, goes down. That's going to be -3. F of -3 is right there at an output of 0. That's undefined. All right, and now composition. This is g of f of 4, really. So let's find out what f of 4 is. So I'm going to go to my function. F of 4, you kind of use yellow to highlight this one. F of 4 is going to be that point right there, which is going to be -1. So now it's saying, okay, well, what's g of -1? So I have to now go to -1, and that g function is -3. So that will be a -3. All right, let's try the next one here. Again, I use a different color because my graph's getting pretty full. Composition f of g of -2 this time. So we're going to go to g of -2. So -2 is my input. Go down to g. That's at -3. So then I'm going to take f of -3. So f of -3 is 0. All right, now these ones are already written in that parenthesis notation, so that's kind of nice. So I look at g of 4. G of 4, I'm going to go to my input of 4 and go down, actually not up, down, up, and it's right there. It's 0. So we're going to plug in that, and we'll get f of 0. So f of 0, we go to input of 0 and go up to function f, it's 3. All right, now the next one, f of -1. Let's find one more color here. Let's see, f of -1. So I go to -1, f would be 2. And so g of 2, I then go to 2, and I want g of 2, which is -1. All right, hope that helped.